Everybody, I really like this next subject about hybridization and sigma and pi bonds. I guess we'll first tackle hybridization because I feel like this is a nice bridge between what we learned about in terms of atoms and orbitals like sps and ds, and then molecules that are covalently bonded. Let me get rid of my face here, and I tried something new here. I tried to do a black background, so we're going to see how this works. But let's move forward and let's talk about hybridization. Okay, hybridization is a theory, and it's wrapped up in this hybrid orbital theory. Okay, I don't ever abbreviate this. But I guess you could as HOT, hybrid orbital theory. But the idea is that when you make a compound, it mashes together the orbitals that the atoms have. So you'll remember that orbitals S, P, D, and F exist in atoms. Some atoms have occupied S's, like hydrogen. Some have occupied S's and P's. But the idea here is that when you make molecules, the atomic orbitals kind of mash together based on how many bonds you need, and they form, instead of having an individual S, which is a sphere, and maybe a P that's like this, they call it dumbbell shaped, right? And this one's three-dimensional, this one's coming out of the computer screen at you. Okay, those are your P's. Those guys can mash together, and maybe, well, what's a sphere plus a P orbital? Well, you end up with a really big lobe sphere and then a really small dingus at the end of this, okay, where the electrons can exist. And that's what the molecular orbital looks like. So it's a hybrid, it's a cross between these two. In biology terms, it would be like a liger, a lion and a tiger. They mash together and you get a liger. Okay. There's also tigons. Okay. It depends on who the mother is how they name them. But in terms of theory, what hybrid orbital theory is able to do is explain why bonds are so strong. Okay, and so that explains why you have single, double, triple bonds and why they're stronger as you get more and more of them. Okay, so here's the idea. Okay, here are the pictures. You can see these guys and what ends up happening. Okay, let's move along. Okay, and so for the purposes of this class, unfortunately, kind of what I want to do is I kind of want to get us the easy way out. And I don't mean to take the easy way out, but I guess I will. Okay, and so here's what we're going to do. Each of these atoms is hybridized. Okay, its orbitals are hybridized because they're bonded in a molecule. Okay, and so carbon, for example, that is hybridized, and how many bonds does it have? Okay, it's hybridized so that we can get two bonds, or two bonding domains. Okay, or sorry, two, look, here I am, two electron domains. So this has two electron domains. Okay, 1, 2. Remember, multiple bonds count as just one electron domain. And so what we need to do is we need to mash two atomic orbitals together to make two hybrid orbitals. So we're going to take the lowest energy orbital, the S, and then we're going to take a P orbital, and we're going to mash those together. We took two orbitals, the S's and the P's, and then we're going to make an SP and an SP. So we have basically said that this carbon is SP hybridized. Okay. Now, this oxygen is also bonded. Okay. Well, how many electron domains do we have here? 1, 2, 3. So this has 3 electron domains. So we have to mush together 3 atomic orbitals. So we're going to start again with the S. Then we're going to do a P, but then we're going to do another P. Remember, there's only one S orbital, but there's 3 P orbitals. And so what we have done is we have taken our 3 atomic orbitals and mashed them together and made an sp2, an sp2, and an sp2 hybridized orbital. So there's 3 hybridized orbitals here to take place of the 3 atomic orbitals for where the electrons are. Okay, and so that's what we're talking about, places where electrons are. Okay, so let's look at this example here. This is kind of fun. Okay, so carbon, again, carbon has, in this example, has 2 electron domains. So if it's 2 electron domains, we're going to hybridize 2 electrons, so that carbon is sp hybridized. Okay, there's 2 sp hybridized orbitals in there. Here, there's 2 electron domains, sp hybridized. When there's 2 electron domains, we hybridize the sp, so this guy is sp hybridized. So it's just counting the electron domains and mashing those together. What if we have 4 electron domains around an atom? Well, that's going to be sp3 hybridized. We're taking the s's and the 3 p's, we're shoving them all together. How many orbitals did we combine? 4, 1 for each electron domain. And then we made 4 sp3 hybridized orbitals that are all the same. Okay. Now, trick question, what if we get up to 5 electron domains? Okay. Well, 5 electron domains, remember we run out of p orbitals, there's only 3. What's the next one that we fill? Well, we can hybridize d orbitals in there, so it can keep going and going and going. Okay, but it's kind of fun. So let's take a look at some of these atoms, and now these are kind of big and ugly, and they look complex and complicated, but they're not really. This is caffeine. Okay, it's caffeine, E-I-N-E. I-E-N-E, I don't know, somebody tell me. And this is urea, a compound in urea, in your pee, urine. Okay, so what I'm asking for you to do is determine the hybridization of each carbon, nitrogen, and oxygen. Let's only do a couple. Okay, let's look at this nitrogen. How many electron domains are around that nitrogen? Okay, well, I see 1, 2, 3. So that nitrogen is sp2 hybridized. sp2, 3 electron domains mushed together, so there are 3 sp2 hybridized orbitals. How about this nitrogen? Okay, that nitrogen has 1, 2, 3, 4 electron domains, so 4 electron domains, and so we're going to mush together an S and 3 P's, and there'll be 4 sp3 hybridized orbitals. Okay, how about that oxygen? Again, 1, 2, 3, so that's going to be an sp2 hybridized oxygen. Okay, so now let's come back over here. Let's look at urea. Okay, we can keep going on these all night long if we wanted to, but I don't want to, I don't want to beat the dead horse here. Okay, so this oxygen has 3 electron domains, so we're going to shove together 3 atomic orbitals to make sp2, so that's an sp2 hybridized oxygen. Keep in mind there's 3 hybridized orbitals putting those together. Okay, nitrogen, how many electron domains? 4, so that makes this an sp3 hybridized nitrogen. Is carbon, 3 electron domains, so that makes it sp2 hybridized. Okay, on down the line. So anyways, that's hybridization. I think it's pretty straightforward, but whenever I do hybridization, it always makes me feel smart because I'm looking at the structure and then I'm finding out more and more about the molecule. So that's pretty cool. Yep, have a great day.